The story of Earth's formation is as old as our solar system itself, and to understand how it came to be, we need to look far beyond the birth of our planet. The tale begins in a time when our planet was not even a thought, not a glimmer in the universe's eye. To grasp the full scope of this remarkable journey, we must travel back nearly 4.6 billion years, at least 4.5 billion years before present, at a time when the Earth had yet to exist in any recognizable form. In fact, there wasn't even a planet Earth or an Earth-like environment yet. Instead, space was filled with swirling gases and dust, ingredients that would eventually come together to form our home. To understand the formation of Earth, we must first look to the stars. About 5 to 6 billion years ago, a massive star, what we now call a solar nebula, began its death throes. It had burned through its nuclear fuel, creating heavier elements like carbon, oxygen and iron in its core, but its time was running out. As this star collapsed inward, it underwent a supernova explosion, releasing enormous amounts of energy and scattering vast amounts of matter into space. These stellar remnants were rich in heavier elements like iron, silicon and aluminum, elements that would later become the building blocks of planets, including Earth. The explosion not only created these new elements, but also sent shockwaves throughout the surrounding space, causing clouds of gas and dust to start to compress under gravity. This set the stage for the birth of our Sun and the formation of the planets that would orbit it, including Earth. The death of that star marked the beginning of a new era. After the supernova explosion, the leftover gas and dust began to swirl together in space due to gravity, creating a giant rotating disk. This is known as the solar nebula. The nebula consisted primarily of hydrogen and helium, the two most abundant elements in the universe, but also included the heavier elements formed in the star's death. As the nebula contracted, it began to spin faster, and the material within the disk began to cool. Near the center, the temperature rose significantly, leading to the formation of the Sun. This process took place about 4.6 billion years ago, marking the beginning of our solar system. The Sun formed through nuclear fusion, where hydrogen atoms fused to create helium, releasing energy and creating a massive gravitational force. This gravitational force attracted more matter, and over time the Sun became the star we see today. Meanwhile, in the outer regions of the solar nebula, the dust and gas began to come together, forming smaller clumps of material. These clumps collided and stuck together, eventually forming larger objects known as planetesimals. These planetesimals were rocky and icy bodies that would later become the building blocks of the planets. As these planetesimals continued to collide and accumulate, the materials began to form larger and larger bodies. Some of these larger bodies were known as protoplanets. Earth's formation took place as a part of this ongoing process. Roughly 4.5 billion years ago, a protoplanetary disk of material that would eventually become Earth started to take shape. The Earth was not formed all at once, but through a gradual process. The early Earth was hot and molten, bombarded by constant impacts from smaller planetesimals. These impacts caused massive heat, and the planet's surface remained molten for a long time. As these planetesimals collided with the forming Earth, the collisions generated enormous amounts of heat, which further contributed to the molten state of the planet. This phase of intense collisions is known as the Late Heavy Bombardment. One of the most significant impacts during this period was the collision with a Mars-sized object, which some scientists call Theia. This impact, occurring around 4.5 billion years ago, was so violent that it caused a massive chunk of Earth's mantle and crust to be ejected into space. This debris eventually came together to form the Moon. The formation of the Moon was a key event in Earth's development, as it played a major role in stabilizing the planet's axial tilt, which in turn stabilized the planet's climate over millions of years. The impact with Theia also caused Earth to become even more molten. The resulting heat led to the differentiation of the Earth's interior. Heavier elements like iron and nickel sank toward the center, forming the Earth's core, while lighter elements such as silicon and oxygen rose toward the surface. This differentiation process led to the formation of the core, mantle, and crust, the basic structure of the Earth we recognize today. In the early stages, Earth's surface was constantly bombarded by meteors and other space debris. This created a violent and hostile environment with extreme temperatures and volcanic eruptions. There was no atmosphere as we know it. Earth's early atmosphere was primarily made up of hydrogen, methane, and carbon dioxide, with very little oxygen. But as the planet began to cool, the volcanic activity released water vapor into the atmosphere. This water vapor eventually condensed, forming the first oceans on Earth. This period, known as the Hadean Eon, lasted from around 4.6 billion years ago to about 4 billion years ago. It was a time of tremendous geological activity, with the planet's surface constantly changing due to volcanic eruptions, asteroid impacts, and the cooling of the planet. The formation of the oceans was a critical event because it created the conditions necessary for life to begin. The presence of water, combined with the cooling of the Earth's surface, eventually led to the creation of a more stable environment. The oceans provided a medium for chemical reactions, and over millions of years these chemical processes would lead to the formation of the first simple life forms. The oceans, however, were also an important buffer for the planet's atmosphere. They absorbed gases like carbon dioxide and played a major role in regulating the Earth's climate. The Moon, which formed shortly after the impact with Theia, played a crucial role in shaping the Earth's development. The gravitational pull of the Moon stabilized the Earth's axial tilt, preventing the planet from experiencing extreme shifts in climate. This stability is one of the reasons Earth became a hospitable place for life to develop. The Moon's gravitational influence also contributed to the creation of the tides. These tidal forces played an important role in the development of early life, as they caused the waters to move and mix, allowing for the movement of nutrients and other essential elements that early life forms needed. As Earth continued to cool over millions of years, the outer surface solidified into a crust, the thin outer layer that forms the land masses of our planet. Beneath the crust lies the mantle, a thick layer of molten rock that moves slowly over time, causing the surface of the Earth to shift. This process of plate tectonics, where large sections of the Earth's crust, called tectonic plates, move and interact, would later become an important force in shaping the planet's surface and its geography. At this point, Earth was no longer a molten ball of rock, but a solidified planet with a crust, oceans, and an atmosphere. However, the planet's surface was still very different from the one we recognize today. Earth's crust was relatively thin, and volcanic activity continued to shape the landscape. There was still very little life, and the atmosphere was not yet the oxygen-rich mixture we rely on today. The Earth was still very much in its infancy, and the stage was set for the rise of life, which would take millions of years to develop fully. As the years passed, Earth's environment became increasingly stable. The cooling of the planet allowed for the solidification of the crust, the formation of oceans, and the eventual development of a more complex atmosphere. Volcanic activity continued, but the planet had begun its slow transition from a violent and inhospitable world to the home of life. From these humble beginnings, Earth would continue to evolve, eventually giving rise to life forms. But even in these early days, the conditions were right for life to emerge, if only in its simplest forms. The process of Earth's formation was not quick or easy, but it set the stage for everything that followed. The formation of Earth was an extraordinary, complex process that took place over billions of years. From the death of a star to the collision that formed the Moon, every step in this process was essential in creating the planet we live on today. The young Earth was a chaotic and violent world, but it eventually cooled and stabilized, creating the conditions necessary for life to take hold. In this episode, we've journeyed through the early history of our planet, from the formation of the solar system to the creation of the Earth's crust and oceans. The next steps in Earth's history would see the rise of life and the dramatic changes that would follow. This is just the beginning of Earth's long journey, a journey that continues to shape our world even today. Stay tuned for our next chapter as we delve into the earliest life forms that arose on this planet, setting the stage for the complex and diverse life we see today.